Good evening. Take a deep breath and allow the tiredness of the day to dissolve into softness. Today, you will travel through the solar system in a way you never imagined possible, not as an explorer eager for frenetic discoveries, but as a serene contemplator, like someone observing clouds gliding in slow motion across an infinite sky. You don't need telescopes or spaceships. You just need to close your eyes, feel the comfortable weight of your body resting, and let your consciousness float gently beyond the atmosphere to that vast and welcoming silence where planets dance in millennial orbits, where moons spin in rhythm of a cosmic waltz, where sunlight travels slowly like golden honey pouring through space. This is not a place of urgencies or dangers. It is a celestial garden, ancient and patient, where each object possesses its own silent melody, its own cosmic breath. And you are invited to simply observe, feel, and let the weight of terrestrial gravity transform into lightness, into deep peace, into gentle slumber as the most tranquil secrets of the solar system whisper in your ear. You breathe slowly and realize that the air in your lungs is made of elements forged in the heart of ancient stars. Oxygen, carbon, nitrogen, all came from stellar explosions that occurred billions of years before you existed. Your body is literally made of stardust, and that's not poetic metaphor, it's scientific fact translated into enchantment. With each inspiration, you connect with the entire cosmos, as if breathing the same substance that forms colorful nebulas in the depths of space. And this connection is not frightening, it is not alienating, it is deeply comforting, like discovering that you have always belonged to something greater, to a cosmic family that stretches across unimaginable distances. The universe is not cold and hostile, it is simply vast, and within that vastness there is a serene order, a harmonious dance that continues since the beginning of time. Now you gently float away from Earth, rising through invisible layers of atmosphere. The air becomes rarefied, but you don't miss it, because this journey happens only in the imagination, in that inner space where there is no cold, no vacuum, just the feeling of calm expansion and gentle curiosity. You cross the thermosphere, where satellites orbit in silence, reflecting sunlight like luminous pearls scattered around the planet. Earth, seen from above, is a blue and white globe spinning slowly, with clouds that look like brushstrokes of watercolor paint on an oceanic background. There are no visible borders, no divisions, just an entire planet breathing together, wrapped in a thin film of air that protects all known life. And you realize, with a tranquil clarity, that this little blue dot is home to billions of stories, and that your own existence is one of them, unique and valuable simply for existing. You continue traveling, and the moon appears on the horizon of your inner vision. It is not the full and bright moon that sometimes frightens with its intensity. It is the serene moon, the moon of calm nights, the moon that has always been there, faithful companion of Earth for more than 4 billion years. It rotates in sync with the blue planet, always showing the same face, like a dancer eternally facing her partner. The lunar surface is marked by craters, valleys, and mountains, but there is no drama in these scars, just history, just time. Each crater is a record of ancient impact, of meteorites that collided millions of years ago, shaping the landscape with geological patience. And the moon doesn't mind. It continues orbiting, creating tides in the terrestrial ocean, pulling the waters with its gentle gravity, making the sea rise and fall in a rhythm that calms, that cradles, that invites deep sleep. The moon's gravity is weaker than Earth's, only 1/6 of the force. If you could walk on its surface, each step would be a slow jump, almost as if you were submerged in crystal clear water. There is no sound there because there is no air to carry sound waves, but that doesn't bring anguish. It brings pure silence, the kind of silence that allows you to listen to your own breathing, your own heart beating in a calm rhythm. Astronauts who visited the moon described the experience as surreal and peaceful, as if they were in a dream where time moves differently. And perhaps that's exactly it. The moon is a place of dreams, a pale reflection of the sun that illuminates our terrestrial nights, guiding travelers, inspiring poets, marking the natural cycles of growth and rest. The moon demands nothing from you. It is simply there, faithful, constant, offering its silvery light as a silent gift. You move a little further away, and now the sun enters your field of vision, not as a blinding midday star, but as a golden and welcoming presence, source of all energy, which sustains life in the solar system. The sun is a sphere of incandescent plasma, where hydrogen atoms constantly fuse into helium, releasing light and heat in a process called nuclear fusion. But don't think of it as something violent. Think of it as a cosmic campfire that burns slowly for billions of years, providing just the right amount of energy for life to flourish on Earth. The sun is not in a hurry. It has enough fuel to continue shining for another 5 billion years. And that brings a sense of permanence, of stability, like knowing that the light that warms your face today is the same that warmed dinosaurs, ancient flowers, primordial oceans, and will continue to warm future generations. Sunlight takes 8 minutes and 20 seconds to reach Earth. This means that at every moment, you are bathed in photons that began their journey just minutes ago, traveling through the vacuum of space at 300,000 kilometers per second. And these photons don't just come from the solar surface. They were created in the sun's core, where nuclear fusion happens, and took tens of thousands of years to traverse the dense layers of the star before finally escaping into space. Each ray of sunshine is, therefore, a story of patience, of perseverance, of a long and silent journey through matter and vacuum until finally touching your skin and warming your soul. And that's comforting, knowing that light is not in a hurry, that everything in the universe happens in due time, without anxiety, without rushing. The sun also has sunspots, cooler regions on its surface that appear as dark spots. These spots are not permanent. They come and go in cycles of approximately 11 years, increasing and decreasing in number according to the star's magnetic activity. But even these variations don't bring chaos. They bring rhythm. They bring natural cycles that remind us that everything in the universe breathes, expands and contracts, shines brighter and then softens, like cosmic lungs breathing through ages. The sun is the anchor of the solar system, the gravitational center that keeps all the planets in their orbits. And there is something deeply reassuring about that, knowing that despite all the movement, despite all the vastness, there is a central point that organizes everything, that keeps the celestial dance working with mathematical precision and natural beauty. You look away from the sun and let your consciousness slide to the first planet in the system, Mercury, the smallest of the rocky planets, the one that orbits closest to the central star. Mercury does not have a significant atmosphere, and therefore its temperatures vary dramatically between day and night, from extremes of heat to extremes of cold. But you are not there to feel these temperatures. You are just watching from afar, noticing the gray, cratered surface which resembles Earth's moon. Mercury rotates slowly on its own axis, so slowly that a Mercurian day, the time it takes to complete one rotation, lasts almost 59 Earth days. This means that dawn on Mercury happens in super slow motion, with the sun rising slowly on the rocky horizon, gradually climbing through the black sky, remaining there for Earth months before finally setting. It's a different, alien rhythm, but not disturbing, just different, reminding us that time is relative, that each world has its own cadence, its own version of day and night. Despite its proximity to the Sun, Mercury has water ice in its polar craters, hidden in permanent shadows where sunlight never reaches. This ice has existed for millions of years, preserved in the eternal colds of these dark regions, and that is curious, almost paradoxical. A planet that faces extreme heat during the day, but maintains ancient ice in its most protected corners. And you realize that even in the most unlikely places, even where we don't expect it, there are gentle surprises. There are elements of freshness and preservation. Mercury is not a planet of life, not a planet of human stories, but it is a planet of silent contrasts, of lessons about adaptation, about how the universe keeps secrets in its darkest recesses. Now you move to Venus, the second planet, the one that shines most brightly in the Earth's sky at dawn or dusk, known as the morning star or evening star. Venus is almost identical in size to Earth, and for that reason, it has been called a sister planet, but its characteristics are radically different. The Venusian atmosphere is thick, composed mainly of carbon dioxide, with clouds of sulfuric acid floating at high altitudes. The atmospheric pressure on the surface is crushing, equivalent to being submerged almost a kilometer deep in the Earth's ocean. Temperatures exceed 450 degrees Celsius, hot enough to melt lead. But you are not worried about that, because he's just observing, floating above the dense clouds, noticing the strange beauty of this world shrouded in a yellowish veil. Venus spins on its own axis in a retrograde manner, that is, in the opposite direction to most other planets. Furthermore, its rotation is extremely slow. A Venusian day lasts longer than a Venusian year, which means that the planet completes an orbit around the Sun before completing a rotation on itself. It is an inverted cosmic dance, disconcerting at first glance, but also fascinating, like watching a dancer who moves in the opposite direction to everyone else, creating unique beauty precisely because it is different. And you understand, at some deep level, that there is no right way to spin, no right way to exist. Each planet has found its own rhythm, its own way of inhabiting space and time. Despite its extreme conditions, Venus holds a relaxing lesson. It reminds us that beauty can exist even where life cannot flourish. The Venusian clouds reflect much of the sunlight, making the planet extremely bright when viewed from Earth. This luminosity has inspired countless cultures throughout human history, associating Venus with love, beauty, femininity. And perhaps there is wisdom in this, recognizing that not everything needs to be habitable to be admirable, that not everything needs to welcome us to inspire us. Venus is a planet for distant contemplation, of beauty that is appreciated from afar, without the need to touch, without the need to possess. You then return to Earth, but now you see it from a renewed perspective, like someone returning from a trip and noticing details that had previously gone unnoticed. Earth is the third planet from the Sun, located in a habitable zone, where the temperature allows for the existence of liquid water on the surface. Water, this simple substance, composed of 2 hydrogen atoms and 1 oxygen atom, which covers approximately 70% of the Earth's surface, creating oceans, rivers, lakes, clouds, glaciers. Water is a catalyst for life, a universal solvent, a substance that allows complex chemical reactions, that regulates temperature, that transports nutrients. And Earth has water in abundance, a cosmic luxury that is not found anywhere else in the solar system on this scale and accessibility. The Earth's atmosphere is thin but essential, a layer of gases that protects the surface from harmful solar radiation, which maintains a stable temperature through the natural greenhouse effect, which allows the respiration of aerobic organisms. This atmosphere is not static. It circulates constantly, driven by the uneven heating of the sun, creating winds, storms, weather fronts. But even the Earth's storms have their role in distributing heat, irrigating distant lands, renewing ecosystems. And you realize that even what seems chaotic has an underlying order, that even what seems disturbing is part of a larger balance, of a planetary homeostasis that has been self-regulating for billions of years. The Earth has a magnetic field, generated by the movement of liquid iron in its outer core. This magnetic field creates a protective bubble around the planet, called the magnosphere, which deflects charged particles coming from the solar wind. Without this invisible protection, the Earth's atmosphere would be gradually stripped away by the constant flow of solar particles, making the surface uninhabitable. But the magnetic field is there, working silently, without you needing to think about it, without you needing to do anything. Just one more of the countless layers of protection that allow your peaceful existence. And this brings gratitude, a gentle feeling of appreciation for all the invisible mechanisms that sustain life, that make possible this moment of rest, this moment of calm breathing. The Earth also has tectonic plates, fragments of the crust that move slowly over the partially molten mantle, creating mountains, oceans, continents. This movement is imperceptible in everyday life, only a few centimeters per year, but over millions of years, it completely transforms the planetary geography. Continents separate, collide, form supercontinents, and then fragment again. It is a patient geological dance, a constant transformation that takes place on a timescale so vast that it seems eternal to human eyes. And there is something deeply relaxing in this, knowing that change is natural, that nothing remains exactly the same, but that this change happens slowly, gently, without haste, without sudden violence. Now you look at Mars, the fourth planet, known as the red planet due to the oxidation of iron on its surface, which gives it a characteristic orange color. Mars is smaller than Earth, with gravity equivalent to about 1/3 of Earth's. Its atmosphere is rarefied, composed mainly of carbon dioxide, and the temperatures, they range from icy cold to moderate, depending on location and season. But Mars is not a place of fear. It's a place of curiosity, of calm exploration, of imagining what could have been and what may yet be. Evidence suggests that Mars, in the distant past, possessed liquid water on its surface, with rivers, lakes, and possibly oceans. Dry valleys and mineral deposits indicate that water flowed there for long periods before the planet lost much of its atmosphere and became the cold desert it is today. But this story isn't sad. It's just history, a record of transformation, reminding us that worlds also age, also go through phases, also have their own narratives of birth, peak, and decline. And perhaps, in some distant future, Mars can be terraformed, transformed again into a habitable world through human technology and patience. Or perhaps not. And that's okay too, because Mars has already fulfilled its role in the solar system, has already brought its lessons, has already enchanted generations of Earth observers with its reddish light in the night sky. Mars has 2 small moons, Phobos and Deimos, which look more like asteroids captured by Martian gravity than natural satellites formed alongside the planet. Phobos orbits so close to Mars that it gradually gets closer and closer, and eventually, in tens of millions of years, it will be torn apart by tidal forces, forming a temporary ring around the red planet. But that's so far in the future that it doesn't cause concern, just curiosity. Just fascination with the impermanence of everything, with the fact that even moons have life cycles. Even celestial objects are born and die, transforming into new forms. And you take a deep breath, accepting this impermanence as a natural part of existence, as a truth that liberates instead of imprisons. You move away from the inner rocky planets and cross the asteroid belt, a region between Mars and Jupiter where millions of rocky fragments orbit the Sun in varied trajectories. These asteroids are remnants of the formation of the solar system, material that never coalesced into a planet due to Jupiter's gravitational influence. But the asteroid belt is not a dangerous minefield as it's sometimes portrayed in movies. The distances between individual asteroids are immense, and navigating this region would actually be a rather solitary and peaceful journey. You imagine passing between these ancient rocks, observing their irregular surfaces illuminated by the distant sun, each with its own history of collisions and orbits, each unique in composition and shape. And then you arrive at the gas giants, starting with Jupiter, the largest planet in the solar system, a massive sphere composed mainly of hydrogen and helium. Jupiter has no solid surface. If you tried to descend through its atmosphere, you would pass through increasingly dense layers of gas until you finally reached a rocky or metallic core surrounded by hydrogen in a liquid or metallic state. But you don't need to descend. Just observe from afar, admiring the colorful bands that encircle the planet, cloud patterns created by intense winds that blow in alternating directions, forming atmospheric zones and belts. Jupiter's most famous feature is the Great Red Spot, a gigantic storm that has lasted for at least 350 years, possibly much longer. This storm is larger than the entire Earth, with winds exceeding 400 kilometers per hour. But even though it's a storm, there's something hypnotic about its persistence, about its oval shape that rotates slowly, about its reddish hues created by complex chemical compounds. You don't feel fear of this storm because you're just observing, floating in imaginary safety, realizing that even violent phenomena can be beautiful when seen from the right perspective, when understood as part of larger natural processes. Jupiter has at least 79 known moons, each with its own characteristics. The four largest, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in 1610, marking one of the first astronomical observations that confirmed that not everything in the sky revolves around the Earth. Io is a volcanic moon, with hundreds of active volcanoes ejecting sulfur in constant eruptions, painting its surface with vibrant yellows and oranges. Europa has a global ocean of liquid water under an ice crust, possibly habitable for simple life forms. Ganymede is the largest moon in the solar system, larger even than the planet Mercury, possessing its own magnetic field. Callisto is an ancient and cratered moon, a geological record of billions of years of impacts. Each of these moons could be the object of contemplation for hours, but what is most relaxing is realizing the diversity, the infinite variety of worlds within a single system. Planetarium. There is no monotony in the cosmos. There are only infinite variations on basic themes: rocks, ice, gases, gravity, light, motion. And each variation is valid. Each world possesses its own dignity, its own place in the silent symphony of the solar system. Jupiter also functions as a protective shield for the inner planets. Its immense gravity attracts comets and asteroids that might otherwise collide with Earth. Throughout the history of the solar system, Jupiter has likely captured or diverted countless dangerous objects, acting as an invisible guardian, as a silent protector who never asks for recognition. And you feel gratitude for this, for all the natural processes that conspire, without conscious intention, to allow life to flourish on a small blue planet orbiting an ordinary star in a galaxy among billions. You continue the journey and encounter Saturn, the sixth planet, famous for its spectacular rings. Saturn is a gas giant, similar to Jupiter, but less massive, with a density so low that it would float on water if there were an ocean large enough to contain it. This image, an entire planet floating, brings lightness, brings a sense of impossibility made real, of a cosmos that does not adhere to human expectations of how things should be. Saturn's rings are composed of billions of particles of ice and rock, ranging in size from microscopic grains to fragments the size of houses. These particles orbit the planet in perfectly aligned trajectories, creating a flat, bright structure that stretches for hundreds of thousands of kilometers, but is only a few dozen meters thick. When you observe these rings, you perceive symmetry, order emerging from chaos, mathematical beauty translated into physical form. And there is something deeply relaxing in knowing that order exists naturally, that it does not need to be imposed, that it arises spontaneously when conditions are right. Saturn's rings are not permanent. Studies suggest that they are relatively young in astronomical terms, perhaps formed only a few 100 million years ago, and will eventually disappear, shattered by tidal forces or absorbed by the planet. But this ephemerality does not diminish their beauty. If anything, it intensifies it, reminding us that everything that is beautiful is also temporary, that genuine appreciation requires presence, requires careful observation while there is still time. And you take a deep breath, accepting this truth, allowing it to bring not sadness, but a sense of gentle urgency, of valuing the present moment. Saturn has more than 80 known moons, with Titan being the largest and most fascinating. Titan is the only moon in the solar system with a dense atmosphere, composed mainly of nitrogen with traces of methane. Its surface has lakes and seas of liquid hydrocarbons, methane and ethane in polar regions, creating an alien landscape where rain is not water but liquid methane, where rivers carve valleys through ice rock, where clouds form and dissipate in a hydrological cycle completely different from Earth's. Titan is a place of scientific curiosity, of exotic possibilities, of remembering that life, if it exists elsewhere, can be radically different from what we know, based on alternative chemistry, on different solvents, on conditions that would seem impossible to terrestrial eyes. You move away from Saturn and travel even further, crossing the orbits of increasingly cold and remote planets. Uranus is the seventh planet, an ice giant with a blue-green color caused by methane in its atmosphere. What makes Uranus especially curious is its extreme axial tilt. The planet rotates practically on its side, with its axis of rotation almost perpendicular to the orbital plane. This means that, during part of its long year, Uranus takes 84 Earth years to complete an orbit around the Sun. One of the poles is constantly illuminated, while the other remains in darkness, creating seasons radically different from anything experienced on Earth. But even this strangeness does not bring discomfort. It only brings fascination, reminding us that the universe does not follow human rules of how planets should behave. Uranus decided to rotate on its side, and it continues to rotate like that, unperturbed, indifferent to expectations, simply existing in its own tilted truth. And perhaps there is a lesson in this, that each being, each object, each existence has the right to be exactly as it is, without the need for justification, without the need for conformity. Neptune is the eighth and last official planet of the solar system, another blue ice giant, but with deeper tones than Uranus, almost cobalt, caused by a slightly different atmospheric composition. Neptune is a planet of extreme winds, the fastest in the solar system, reaching speeds of over 2,000 kilometers per hour. But you are not worried about these winds. It's just admiring the distance, realizing how this planet orbits so far from the Sun that it receives only a minuscule fraction of the light and heat that illuminate Earth. A day on Neptune receives approximately 1,000 times less solar energy than a day on Earth, and yet the planet has an active atmosphere, dynamic storms, internal movements that generate its own heat. Neptune doesn't depend solely on the Sun. It possesses internal sources of energy, reminding us that independence can be found even in remote places, that vitality doesn't require constant proximity to external sources. Neptune has a moon called Triton, which orbits the planet in a retrograde direction, suggesting it was captured from the Kuiper Belt, a region beyond Neptune where countless icy objects reside. Triton possesses geysers of liquid nitrogen that eject material from the surface, creating plumes that spread through the rarefied atmosphere. These geysers aren't violent, they're gentle, almost poetic, reminding us that geological activity can exist even in icy worlds, that movement and change don't cease just because the temperature is low or because the distance from the sun is great. Beyond Neptune, you find the Kuiper Belt, a vast region of icy objects that extends from Neptune's orbit to approximately 50 astronomical units from the sun. Pluto, formerly considered the ninth planet and now reclassified as a dwarf planet, resides in this region, along with Eris, Makemake, Haumea, and thousands of other smaller objects. Pluto isn't sad to have been reclassified. It feels nothing, because it's just rock and ice spinning in space, indifferent to human categories. And there's wisdom in recognizing this, that names and classifications are human tools for organization, but they don't change the essence of things. They don't alter the fundamental reality of the objects that orbit silently, fulfilling their millennial trajectories. Pluto has a moon called Charon, almost half its size, and the two orbit a common center of mass, forming a binary system. They're locked in synchronous rotation, always showing the same face to each other, like two dancers eternally embraced, spinning together through the cold darkness of outer space. And there's something touching in this image, something that evokes partnership, companionship, the idea that even in the most remote places, even on the icy frontiers of the solar system, there's no absolute solitude. There's always some form of connection, always some gravitational bond that unites objects in a cosmic dance. You realize then that the solar system doesn't end abruptly. Beyond the Kuiper Belt, there is the Oort cloud, a hypothetical spherical region that surrounds the entire solar system, extending up to 100,000 astronomical units, almost half the distance to the nearest star. The Oort cloud is home to trillions of cometary nuclei, icy fragments that orbit the sun in extremely distant trajectories, rarely disturbed except by occasional passages of nearby stars or gravitational fluctuations of the galaxy. These comets are rare visitors to the inner planets. When disturbed, some fall towards the sun, developing bright tails as ice sublimates under solar radiation, creating visual spectacles that have inspired awe and admiration in human cultures throughout millennia. Comets aren't messengers of doom, despite ancient superstitions. They're just blocks of dirty ice following extremely elongated orbits, occasional visitors that bring reminders of the solar system's formation, preserving within them primordial chemical compounds, organic molecules that may have contributed to the emergence of life on Earth when comets collided with the young planet, depositing water and organic compounds on its surface. And you realize that even events that seem chaotic, collisions, impacts, unexpected encounters, can be part of larger creative processes, can be seeds of positive transformation, can be catalysts for new beginnings. You float now in the absolute silence of interplanetary space, feeling not the cold or the vacuum, but the serene vastness that permeates everything. Between the planets, between the orbits, there's mostly empty space. Immense distances where there's nothing but occasional hydrogen atoms, cosmic rays traveling at relativistic speeds, and the soft light of the sun gradually diminishing as it moves away from the source. This emptiness isn't frightening. It's peaceful. It's liberating. It's space to breathe on a cosmic scale. And you understand, on some deep level, that the universe is made mostly of emptiness. that solid objects, planets, stars, galaxies, are rare exceptions in an ocean of space, and that this is the natural order of things, that there's no need to fill every inch with matter or meaning. The space between planets is traversed by the solar wind, a constant flow of charged particles ejected by the solar corona. This wind travels at speeds of hundreds of kilometers per second, carrying the sun's magnetic field with it, creating a structure called the heliosphere, an invisible bubble that surrounds the entire solar system and partially protects it from cosmic rays coming from interstellar space. The heliosphere extends far beyond the orbit of Pluto to a region called the heliopause, where the pressure of the solar wind balances with the pressure of the interstellar medium. The Voyager probes, launched by humanity in 1977, crossed this boundary in recent years, becoming the first human-built objects to enter interstellar space. They continue to transmit data as they move away, solitary messengers carrying golden records with sounds and images of Earth in the unlikely hope that some distant civilization may find them and learn a little about the beings who created them. This image, ancient probes traveling through the dark, carrying music and human voices, brings a gentle melancholy, but not sadness. It brings a sense of legacy, of reach, that even on a cosmic scale, efforts matter, symbolic gestures have value, hope persists despite the odds. And you take a deep breath, accepting this truth, allowing it to inspire, not despair in the face of vastness, but quiet courage, a recognition that doing something is always better than doing nothing, even when results are uncertain, even when distances seem insurmountable. Now you return your attention to more subtle, more ethereal phenomena of the solar system. The zodiacal light, for example, a diffuse glow visible on dark nights after sunset or before sunrise, caused by the reflection of sunlight on dust particles orbiting the sun in the ecliptic plane. This dust is a remnant of comets and asteroids, microscopic fragments that float in their own orbits, creating a luminous haze that extends throughout the solar system. The zodiacal light is not dramatic, it is soft, almost imperceptible, requiring a dark sky and patience to be observed. But its existence reminds us that space is not perfectly clean, that there are invisible textures, layers of diffuse matter that connect celestial objects, that create continuity where there could only be separation. You also contemplate the Lagrange points, special positions in systems of two bodies orbiting each other where gravitational forces balance in such a way that a smaller object can remain relatively stationary in relation to the two larger bodies. In the Earth-Sun system, there are 5 Lagrange points, 2 of which are especially stable and naturally accumulate Trojan asteroids, small rocky objects that share the Earth's orbit, preceding or following the planet in its journey around the Sun. These asteroids do not collide with the Earth because they are trapped in gravitationally stable regions, like balls floating in river eddies, held in place by invisible currents. And there is something comforting in that, knowing that the universe has pockets of stability, places where objects can rest effortlessly, maintained in delicate balance by natural forces. Humanity uses Lagrange points to position space telescopes and satellites, taking advantage of these stable regions for long-term observation without the need for constant orbital corrections. The James Webb Space Telescope, for example, orbits the Lagrange point L2, located approximately 1 million miles from Earth, in the opposite direction from the Sun. From there, the telescope observes the deep universe in infrared, capturing light from galaxies so distant that it traveled for billions of years before finally reaching its sensitive mirrors. And this ability to look back in time, to see the universe as it was in the distant past, brings a humble perspective, reminding us that the present is only a thin slice of cosmic history, that everything that exists now was once different and will be different again. You then perceive the beauty of eclipses, rare alignments that occur when the moon passes between the Earth and the Sun, or when the Earth casts a shadow on the moon. Total solar eclipses are improbable cosmic coincidences. The moon, although 400 times smaller than the Sun, is also 400 times closer to the Earth, causing both to appear approximately the same size in the Earth's sky. This coincidence is not necessary for anything, serves no functional purpose, but creates one of the most sublime spectacles of nature. The moment when the moon perfectly covers the solar disk, revealing the luminous corona that normally remains invisible, transforming day into sudden twilight, bringing a strange silence as birds stop singing and the temperature drops several degrees in minutes. Eclipse observers report a feeling of suspended time, of altered reality, as if for a few minutes the universe revealed. Fundamental secret about dance needs the celestial bodies, and perhaps that's exactly it. Eclipses are moments when the hidden mechanics of the cosmos become visible, when invisible orbits manifest in projected shadows, when abstract mathematics transforms into immediate sensory experience. You don't need to witness an eclipse to feel its impact. Just knowing they exist, that nature occasionally offers perfect alignments, unsolicited gifts that remind us that beauty emerges spontaneously from physical laws, without the need for conscious design. Lunar eclipses are equally fascinating, though less dramatic. When Earth positions itself between the Sun and the full moon, its shadow covers the natural satellite. But instead of disappearing completely, the moon acquires a reddish hue, caused by the refraction of sunlight through Earth's atmosphere. This light, the same kind that creates orange sunrises and sunsets, is curved around the Earth and illuminates the moon with a copper glow, creating a phenomenon called a blood moon. But there's nothing sinister about it. It's just optics, just light behaving according to physical properties, bending through the atmosphere, filtering wavelengths, painting the natural satellite with colors that normally belong to the terrestrial horizon. Now you let your consciousness rest on orbital resonances, mathematical patterns that arise when the orbital periods of two or more bodies have simple ratios to each other. Jupiter's moon system, for example, exhibits Laplace resonance. Io completes 4 orbits for every 2 of Europa and 1 of Ganymede, maintaining a regular alignment that generates rhythmic tidal forces, heating Io's interior and keeping its volcanoes active. These resonances are not coincidences. They are natural results of gravitational interactions over eras, systems that self-adjust until they find stable configurations. And there is music in this, literal harmony in the orbital proportions, like cosmic chords played on a timescale that exceeds direct human perception. Saturn's rings also exhibit resonances with smaller moons, creating sharp divisions where particles are disturbed by regular gravitational influence. The Cassini division, for example, is a prominent gap in the rings caused by resonance with the moon Mimas. Particles that try to orbit in this region are gradually pushed out, maintaining an empty space through a process that lasts millions of years. It is gravitational sculpture, art created by pure physics, without intention, but with a result that is aesthetically pleasing to human eyes, that appreciate symmetry and order. You now contemplate the rotation of the planets, each spinning on its own axis at different speeds. Jupiter completes a rotation in approximately 10 hours, making the Jovian day extremely short, despite the planet's immense size. Venus, on the other hand, takes 243 Earth days to complete a rotation and rotates in the opposite direction. Earth rotates once every 24 hours, creating a circadian rhythm that governs the biological cycles of virtually all living things. These rhythms are not arbitrary. They are evolutionary responses to planetary rotation, internal clocks synchronized with astronomical movement. And you realize that your own body, your own cells, are connected to the Earth's rotation, that you are literally a child of this spinning planet, that your sleep and wake cycles reflect cosmic movement happening beyond your conscious perception. The precession of the equinoxes is another hypnotic phenomenon, the slow movement of the Earth's axis of rotation, which completes a cycle every 26,000 years. This movement causes the North Celestial Pole, currently near the star Polaris, to gradually shift, pointing to different regions of the sky over millennia. In 13,000 years, the axis will point to the star Vega, and Polaris will no longer be the North Star. Ancient civilizations did not perceive this movement in individual lifetimes, but careful astronomers over centuries noticed gradual changes in the position of the constellations in relation to the equinoxes. And there is a profound humility in recognizing that even elements that seem fixed, like the direction of the celestial pole, change when observed on a sufficiently long scale, that absolute permanence is an illusion, that everything in the universe is in motion, in transformation, in constant becoming. You meditate on the age of the solar system, 4.6 billion years, a number so large that it transcends intuitive understanding. This time is sufficient for radioactive elements to have decayed into more stable products, leaving isotopic signatures that allow us to date meteorites and planetary rocks. It is sufficient for life to have arisen, evolved, diversified into millions of species, suffered 5 mass extinctions, and given rise to beings capable of contemplating its own origin. It is sufficient for continents to have moved, oceans to have formed and evaporated, mountains to have grown and been eroded multiple times. And yet, the solar system is only halfway through its lifespan. The sun will continue to shine for another 5 billion years before expanding into a red giant, likely engulfing the inner planets, including Earth. But this eventual destruction does not bring anxiety, because it is so distant in the future that it becomes pure abstraction, an intellectual exercise without immediate emotional weight. It's like contemplating your own aging on a cosmic scale, inevitable, but not urgent, a natural part of larger cycles. And perhaps, long before that happens, terrestrial life will have found ways to migrate to other worlds, or will have evolved into forms so different that individual survival of planets will no longer be relevant. Or perhaps not, and that's okay too, because the universe does not depend on witnesses to continue existing, does not require approval or the presence of consciousness to fulfill its natural processes. You observe now the planetary transits, rare moments when inner planets, Mercury or Venus, pass directly between Earth and the Sun, appearing as small dark spots crossing the solar disk. These events were historically important for calculating the distance between the Earth and the Sun, allowing triangulations that finally revealed the true scale of the solar system. The transit method is also currently used to detect exoplanets around other stars. When a planet passes in front of its host star, it causes a tiny decrease in stellar brightness, detectable by sensitive telescopes. This technique has revealed thousands of worlds orbiting distant stars, showing that planetary systems are common in the galaxy, that the solar system is not an exception but the rule, that there are probably billions of planets in the Milky Way, many of which may have conditions suitable for life. And this discovery brings both humility and hope. Humility because it shows that Earth is not the center of anything, just a common planet in a common system orbiting a common star. Hope because it suggests that life, wherever it arises, is not fundamentally alone, that the universe is potentially rich in consciousness, in observers contemplating mysteries, in beings looking at the night sky and wondering if there is someone else looking back. You feel now gravity differently, not as a force that pulls downwards, but as the curvature of space-time created by the presence of mass. According to Einstein, massive objects like the sun and planets deform the fabric of space around them, creating gravitational wells where other objects roll naturally. Planets do not orbit the sun because they are pulled by an invisible force, but because they follow geodesics, the straightest possible paths through curved space. It's a profound shift in perspective, a conceptual transformation that doesn't alter the math, but revolutionizes understanding. And there is beauty in this vision, imagining space as an elastic surface, deformed by the presence of matter, with objects gliding smoothly through gravitational valleys, creating orbits not by obedience to forces, but by natural movement through curved geometry. This curvature also affects light. Light rays from distant stars are slightly deflected when they pass close to the sun, a phenomenon confirmed during the solar eclipse of 1919, providing one of the first observational evidences of general relativity. Light has no mass, but it travels through curved space, and therefore also follows geodesics, curving in the presence of intense gravitational fields. Black holes take this effect to the extreme. They curve space so intensely that even light cannot escape, creating regions of absolute darkness surrounded by event horizons. But there are no black holes in the solar system, just a moderate star and peaceful planets, objects whose gravity is sufficient to maintain atmospheres and moons, but not to distort reality dramatically. You reflect on the chemical composition of the solar system, on the fact that hydrogen and helium represent approximately 98% of all normal matter, while heavier elements, carbon, oxygen, iron, silicon, constitute only a small fraction. These heavy elements did not exist in the early universe. They were synthesized inside old stars through nuclear fusion, and then scattered through space when these stars exploded as supernovas. The solar system formed from a cloud of gas and dust that contained these recycled elements, remnants of previous generations of stars. And this means that you, composed mainly of carbon, oxygen, nitrogen, and other heavy elements, are literally made of stardust, of matter that has passed through the interior of giant stars, which was heated to millions of degrees, which was ejected in cataclysmic explosions, which floated through space for eons before finally aggregating into a planet where life could arise and contemplate its own origin. This narrative does not diminish the value of existence. If anything, it amplifies it, connecting every atom of your body to the cosmic history of billions of years, transforming common matter into stellar legacy. You are not just human, not just a biological organism. You are also a continuation of processes that began with the first stars. You are also a chapter in the history of matter, transforming from primitive hydrogen into conscious complexity. And there is profound dignity in this. There is meaning, not imposed, but emergent, not given, but discovered through patient investigation of nature. The meteorites that occasionally fall to Earth carry physical messages from this remote past. Some contain chondrules, small glassy spheres formed when droplets of molten rock solidified rapidly in space, preserving information about conditions in the early solar nebula. Others contain amino acids, building blocks of proteins, suggesting that basic ingredients of life may have been delivered to the young Earth by impacts from celestial bodies. These meteorites are not threats. They are unintentional gifts, free samples of the cosmos falling into our backyard, allowing direct study of material that formed along with the solar system, without needing to travel to the asteroid belt to collect it. You now contemplate the seasonal cycles of the Earth, caused by the axial tilts of the planet, approximately 23 degrees relative to the perpendicular of the orbital plane. This tilt causes different hemispheres to receive varying amounts of sunlight throughout the year, creating summer when the hemisphere is tilted towards the sun and winter when it is tilted away. But the seasons are not just about temperature. They are about rhythms, about cycles of growth and dormancy, about flowering and hibernation, about patterns that repeat year after year, creating predictability that allows planning, agriculture, civilization. And there is profound comfort in knowing that spring always returns after winter, that days darken but then lengthen again, that nature possesses reliable rhythms that transcend individual human concerns. Mars also has seasons, although longer due to the extended Martian year. During the Martian winter, atmospheric carbon dioxide freezes at the poles, forming dry ice caps that grow significantly. In the summer, these caps sublimate, releasing gas back into the atmosphere, creating seasonal variations in atmospheric pressure detectable by instruments on Martian rovers. It is a different cycle from Earth's, but equally regular, equally predictable, reminding us that natural patterns are not unique to Earth, that other worlds also breathe through seasons, also possess their own temporal rhythms. You now realize the importance of water in the solar system, not only on Earth, but in many other places. Europa, a moon of Jupiter, has a global ocean of liquid water under an icy crust, kept liquid by tidal heating caused by Jovian gravity. Enceladus, a small moon of Saturn, ejects plumes of water vapor through fissures in its south pole, also suggesting a subsurface ocean. Even Mars, seemingly dry, has abundant water ice at its poles and subsurface. Liquid water is considered essential for life as we know it, and discovering that it is relatively common in the solar system brings renewed hope that microbial life may exist on other worlds, hidden beneath icy surfaces, thriving in dark oceans never illuminated by direct sunlight. This possibility of extraterrestrial life, even within the solar system, does not bring fear of invasion or conflict. It brings scientific curiosity, a desire to know, to study, to compare alternative biology with Earth's. If microbes exist on Europa or Enceladus, they may utilize different biochemistry, unique adaptations to extreme environments, independent evolutionary solutions to similar problems. And studying these life forms, should they be found, would dramatically expand human understanding of what life can be, of how chemistry can organize itself into self-replicating systems, of the limits and possibilities of biology. You now meditate on the concept of the habitable zone, the region around a star where temperatures allow for the existence of liquid water on the surface of rocky planets. In the solar system, this zone includes approximately the orbits of Venus, Earth, and Mars, although only Earth currently has stable liquid water on its surface. Venus is too hot due to a runaway greenhouse effect. Mars is too cold and has an atmosphere too thin to maintain stable liquid water. But this zone, it's not a fixed concept. It depends on star characteristics, planetary atmospheric composition, factors like volcanic activity and plate tectonics, and even outside the traditional habitable zone, moons with subsurface oceans can offer habitable niches, dramatically expanding places where life could exist. This flexibility, recognition that habitability is more complex than simple distance from the star, brings additional hope for the search for life in exoplanetary systems. Stars of different masses and temperatures have their own habitable zones, and rocky planets appear to be common throughout the galaxy. The combination of these discoveries suggests that opportunities for life are abundant in the universe, that the cosmos is likely filled with worlds where complex chemistry could, given enough time, organize itself into biology. You now contemplate the orbital stability of the solar system, wondering if planetary orbits are permanent or will eventually change. Computer simulations show that on extremely long timescales, billions of years, orbits can become chaotic, with small disturbances accumulating until they cause significant changes. Mercury, for example, has a small but real probability of having its orbit destabilized by the gravitational influence of Jupiter, potentially colliding with Venus or falling into the Sun in the distant future. But these changes are so slow, so gradual, that for practical purposes, orbits are stable for periods much longer than the existence of humanity, much longer than the probable duration of humanity. And there is peace in this, recognition that concerns about orbital destabilization are irrelevant for any human timescale, that the solar system will function smoothly for periods so long that they transcend imagination. You don't have to worry about Mercury colliding with Venus. That is a question for a future so distant that the very concept of humanity will probably be unrecognizable or extinct. The present is stable, the near future is predictable, and that's all that matters for conscious existence that lives in seconds, minutes, years. You now observe the cosmic dust that permeates the solar system, microscopic particles of rock and ice that orbit the sun, constantly replenished by collisions between asteroids and the evaporation of comets. These particles are so small that the pressure of solar radiation, literally the pressure exerted by photons colliding with surfaces, affects their movements, creating complex orbits that gradually spiral toward the sun or are expelled into interstellar space. Cosmic dust constantly falls on the Earth, approximately 100 tons per day, slowly adding mass to the planet. But this rate is so low compared to the total terrestrial mass that it is completely insignificant, imperceptible except through careful scientific measurements. Imagining this microscopic snow of stardust falling silently on the planet brings a sense of connection with the larger cosmos, reminding us that Earth is not a closed system, but part of a network of material flows that connect all objects in the solar system. You are constantly being bombarded by atoms that came from distant asteroids, from comets that visited the inner solar system before returning to the dark. And this reality brings not danger, but only curiosity, only fascination with the subtle interconnectivity of everything. The auroras borealis and australis are visible manifestations of this connection between Earth and the Sun. When charged particles from the solar wind collide with molecules in the Earth's upper atmosphere, they transfer energy that is then released as colored light, green from oxygen, red from oxygen at higher altitudes, blue and purple from nitrogen. These dancing lights in the polar sky are not only beautiful, they are physical demonstrations of the Earth's magnetic field working, channeling solar particles towards the poles, protecting the surface from radiation that could otherwise be harmful. And observing auroras is witnessing the interaction between planet and star. It is seeing invisible physics becoming visible. It is experiencing science as natural art. Indigenous peoples who live in polar regions have developed countless cultural interpretations for auroras. Spirits dancing, ancestors celebrating, harbingers of change. And although the scientific explanation is different, it does not invalidate these cultural interpretations. It simply adds an additional layer of understanding. The beauty of the auroras transcends explanation. It remains sublime, regardless of whether one understands plasma physics or not. And perhaps this is an important lesson, that scientific knowledge does not diminish wonder, does not exhaust mystery. It only transforms it, adds depth without removing enchantment. You now contemplate galactic cosmic radiation, high-energy particles, mainly protons, that travel through the galaxy at speeds close to that of light. These particles are accelerated by supernovas, pulsars, and other energetic phenomena, and permeate all of interstellar space. When they enter the solar system, many are deflected by the solar magnetic field, but some still reach Earth, where they collide with atmospheric atoms, creating showers of secondary particles. These collisions are harmless to life on the surface, protected by a dense atmosphere and magnetic field, but they can cause occasional genetic mutations, possibly contributing to evolutionary variation over millions of years. This idea, that cosmic rays from distant stellar explosions may have subtly influenced terrestrial evolution, connects local life with galactic events, suggesting that the history of life is not just the isolated history of a planet, but also the history of how this planet interacts with the larger cosmic environment. Each organism is a product not only of local selective pressures, but also of astronomical context, of location in the galaxy, of protections offered by the magnetic field and atmosphere. And recognizing this expands perspective, transforms biology into a truly cosmic science. You meditate on the formation of moons, wondering how natural satellites arose. Some moons, like those of Mars, are probably asteroids captured by planetary gravity. Others, like many small moons of Jupiter and Saturn, have also been captured. But Earth's moon has a different origin. The most accepted theory is that it formed from debris ejected when the proto-Earth collided with an object the size of Mars approximately 4.5 billion years ago. This giant collision vaporized part of the Earth's mantle, creating a disk of molten matter around the planet, which eventually aggregated to form the moon. This violent origin contrasts with the peaceful present, reminding us that even serene objects have turbulent histories, that primordial chaos eventually settles into stable order. The existence of the moon has been profoundly important for terrestrial life. It stabilizes the Earth's axial tilt, preventing extreme variations that could make the climate unpredictable. It creates ocean tides that were possibly important for early marine life to colonize coasts. And it offers nocturnal light that has influenced the behaviors of countless species, from the navigation of sea turtles to the reproductive cycles of corals. Imagining Earth without the moon is imagining a radically different planet, possibly inhospitable to complex life. And this brings gratitude for a cosmic accident that occurred eons ago, for a collision that could have destroyed the proto-Earth, but instead created the Earth-Moon system, a partnership that allowed life to flourish. You now contemplate the sounds of the solar system, or rather, the absence of them, because sound requires a medium to propagate, and the vacuum of space does not transmit sound waves. But if there were air in space, what sounds would we hear? The sun would emit a deep roar, caused by turbulent convection in its outer layers, vibrations that would make the hypothetical atmosphere pulse with infrasonic frequencies. Jupiter would produce whistles and clicks generated by lightning in its atmosphere and interactions between the magnetic field and charged particles. Saturn would sing with frequencies created by plasma waves traveling through its magnetosphere, sounds that were in fact captured by space probes and converted into audible audio, revealing alien and fascinating melodies, like the songs of cosmic whales echoing through the vacuum. The Earth, seen from afar, would also produce sounds. The constant hum of the atmosphere in motion, winds circulating in global patterns, storms generating thunder that would propagate if there were a medium to transport them. But this absence of sound in space is not a disturbing void. It is a profound silence. It is an absolute stillness that allows reflection without interruptions, contemplation without distractions. It is the kind of silence that is rarely found on Earth, where there is always background noise, wind, water, life, machines. In space, you could float in perfect silence, hearing only your own breathing, your own heart, thoughts without external interference. This silence is also liberating. It means that solar explosions, volcanic eruptions on Io, violent storms on Neptune all happen in complete muteness, without rumble, without cacophony. The universe, despite all its energy, all its movement, is fundamentally silent, and there is a profound serenity in this, a recognition that noise is a local phenomenon, that the cosmic vastness is a place of absolute acoustic peace. You turn your attention to the planetary rings, wondering why some planets have them and others do not. Saturn is famous for its spectacular rings, but Jupiter, Uranus, and Neptune also have ring systems, although much fainter and more difficult to observe. Rocky inner planets lack rings, possibly because they are too close to the Sun, where tidal forces and solar radiation make it difficult to maintain orbital particles. Or perhaps they simply didn't have moons that broke apart to form rings, or didn't capture enough material to create detectable structures. Rings are not static, they are dynamic, constantly losing material to planetary atmospheres or being replenished by collisions between moons and meteoroids. In Saturn, for example, rings are gradually falling onto the planet, pulled by gravity and dragged by the magnetic field. Estimates suggest that Saturn's rings may disappear completely in a few 100 million years, transforming the iconic planet into a common gas giant without annular adornment. But this future loss does not diminish present beauty. If anything, it intensifies it, reminding us that everything is temporary, that true appreciation requires awareness of impermanence. You now contemplate planetary magnetic fields, invisible bubbles of force that envelop some worlds. Earth, Jupiter, Saturn, Uranus, and Neptune possess significant magnetic fields, generated by movements of conductive materials in their interiors. Liquid iron in the case of Earth, metallic hydrogen in the gas giants. These fields are not directly perceptible to human senses, but their presence is crucial, deflecting the solar wind, capturing charged particles, creating radiation belts around the planets. Mercury has a weak magnetic field, suggesting a partially liquid core. Venus and Mars do not have significant global magnetic fields, having lost magnetic protection at some point in their histories, leaving their atmospheres vulnerable to erosion by the solar wind. These magnetic fields are like invisible shields, silent guardians who work constantly without recognition, without fanfare. And there is something comforting in knowing that protection exists in layers: atmosphere, magnetic field, distance from the sun, multiple redundant systems that ensure the safety of terrestrial life. It is no accident that life prospered on Earth. It is the result of specific conditions, of planetary characteristics that combined favorably, of cosmic luck multiplied by billions of years of stability. Now you contemplate the movement of the solar system through the galaxy. The Sun is not stationary in space. It orbits the center of the Milky Way at a speed of approximately 220 kilometers per second, completing a galactic orbit every 225 million years, a period sometimes called a galactic year. Since dinosaurs appeared on Earth, the solar system has completed approximately one galactic orbit. Since the origin of terrestrial life, it has completed approximately 20 orbits. This movement is not perceptible in day-to-day life, but it happens constantly, carrying the solar system through different regions of the galaxy, exposing it to varied environments, molecular clouds, spiral arms, regions more or less dense with stars. This galactic journey brings additional perspective. The solar system is not just a set of planets orbiting a star, it is also a cosmic traveler, navigating through an ocean of stars, participating in a dance much larger than its own internal structure. And you realize that context expands infinitely. First, you are an individual on a planet, then a planet in a solar system, then a solar system in a galaxy, then a galaxy in a universe. Each level of organization reveals a new type of movement, a new time scale, a new perspective on what it means to exist. The Milky Way, the galaxy that contains the solar system, has approximately 200 billion stars, perhaps more. Of these, some are larger and brighter than the Sun, others smaller and fainter. Some are young, newly born from molecular clouds, others ancient, contemporaries of galactic formation. And around many of these stars orbit planets, Recent estimates suggest that practically every star has at least one planet, meaning that the galaxy harbors hundreds of billions of worlds, each with its own characteristics, unique histories, unknown potential. This vastness could be overwhelming, could induce existential insignificance. But it can also be liberating. If the universe is so vast, so full of possibilities, then there is no unique pressure on any individual world, on any individual life. You are free to exist without the weight of cosmic importance, free to simply be, simply experience, simply contemplate without the need to justify existence through universal meaning. Meaning can be local, personal, intimate, and yet completely valid. You now meditate on the temperature of space, wondering how cold would be felt in interplanetary vacuum. In fact, the concept of temperature in a vacuum is complicated because temperature measures the average kinetic energy of molecules, and a vacuum has practically no molecules. An object in space has a temperature determined by the equilibrium between the absorption of radiation, mainly from the sun, and the emission of infrared radiation. Near Earth, in direct sunlight, an object heats up to temperatures similar to terrestrial temperatures, or higher. In the shade, without sunlight, an object gradually cools through thermal radiation, eventually approaching the temperature of the cosmic microwave background, approximately 3 degrees above absolute zero, an echo of the Big Bang that permeates the entire universe. But you don't feel this cold, because this journey is imaginary. It's contemplative. It takes place in a mental space where there is no physical discomfort. You can observe extreme temperatures, crushing pressures, intense radiation, all from a safe distance, absorbing knowledge without risk, learning without danger. And that is the beauty of science. It allows exploration through understanding, travel through thought, connection with distant realities through mathematical abstraction and careful observation. The cosmic microwave background, detected as microwaves permeating all of space, is a relic of the early universe, light emitted approximately 380,000 years after the Big Bang, when the universe cooled sufficiently to allow neutral atoms to form and photons to finally travel freely without being constantly scattered by charged particles. This radiation has been stretched by the expansion of the universe, transforming from visible light into microwaves, but it still carries information about the conditions of the young universe, about density fluctuations that eventually led to the formation of galaxies and large-scale structures. Observing this radiation is literally looking into the distant past, seeing the universe as it was almost at the beginning. And there is something deeply moving in that, the recognition that ancient light still travels through space, that the past does not completely disappear, but leaves detectable traces, that the history of the cosmos is written in radiations, in chemical compositions, in the movements of celestial objects. The universe is an open book for those who know how to read its language. You contemplate now the possibility of life beyond Earth, not as fantastical speculation, but as a legitimate scientific question. The basic ingredients of life, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, are abundant in the universe. Complex organic molecules have been detected in interstellar clouds, in comets, in meteorites. Water is surprisingly common, found not only on Earth, but on moons, asteroids, even on distant exoplanets. Energy is available in multiple forms: starlight, geothermal heat, chemical reactions, so why shouldn't life arise elsewhere? The Drake equation, proposed in the 60s, attempts to estimate the number of communicating civilizations in the galaxy by multiplying factors such as the rate of star formation, the fraction of stars with planets, the number of habitable planets per system, the fraction where life arises, the fraction where life develops intelligence, the fraction of intelligent civilizations that develop communicative technology, and the average lifespan of these civilizations. Depending on the values assigned to each factor, the result varies dramatically from a single civilization, humanity, to millions of civilizations. But even conservative estimates suggest that the probability of us being alone in the galaxy is low. This possibility, that intelligent life exists elsewhere, does not bring anxiety about contact or invasion. It brings curiosity. It brings a desire to know, to compare, to learn from alternative experiences of evolution and consciousness. And even if we never establish contact, even if distances are too great for practical communication, simply knowing that we are probably not alone transforms our understanding of our place in the cosmos, adds a cosmopolitan context to human existence. You return now to home, letting your imagination slowly return to Earth, to the familiar atmosphere, to solid ground under your feet. The journey through the solar system revealed not only facts about planets and moons, but also more subtle truths about connection, about impermanence, about beauty emerging from natural processes. You saw that order coexists with chaos, that stability is dynamic, that change happens on multiple timescales simultaneously. You realized that protection exists in invisible layers, that much of what sustains life operates silently, without fanfare. You recognized that perspective expands infinitely, that context can always be broadened, that you are simultaneously insignificant on a cosmic scale and precious on a local scale. And now, returning fully to bodily awareness, you feel the comfortable weight of your body against the resting surface. Muscles relax progressively, starting with the feet, going up the legs, across torso, descending through arms, releasing tension in shoulders, neck, jaw. Breath becomes even slower, deeper, more rhythmic. Thoughts that once flowed in rapid current now move like honey, viscous, spaced apart, eventually ceasing completely, leaving only silent presence, awareness without specific content. The solar system continues its dance even as you rest. Planets follow millennia-old orbits. Moons revolve around larger worlds. Comets trace ellipses through icy darkness. Cosmic dust falls silently on all objects. The sun continues fusing hydrogen into helium, releasing light that will travel for minutes before touching planetary atmospheres. Earth's magnetic field continues deflecting solar wind. Auroras dance over poles. Tides rise and fall responding to lunar attraction. All this happens independently of human attention, independently of understanding or appreciation. The cosmos simply is, simply exists, simply continues. And there is deep peace in recognizing this, that you don't need to do anything for the universe to function, don't need to maintain constant vigilance, don't need to control or manage. You can simply rest, simply allow natural processes to continue without intervention. Simply trust that morning will arrive, that the planet will continue spinning, that life will continue happening. This trust is not blind faith. It is based on billions of years of precedent, on observable regularities, on physical laws that do not change capriciously. The solar system, seen as a whole, is a stable system. Not perfectly static, nothing in the universe is, but sufficiently stable to allow predictability, planning, security. Orbits are calculable with precision, eclipses can be predicted centuries in advance, future planetary positions can be determined mathematically. This predictability allows space navigation, allows precise timekeeping, allows science. And it also allows mental rest, allows letting go of control, allows acceptance that the near future is knowable, that catastrophic surprises are extremely improbable. You realize that breath has synchronized with deeper rhythms, not just with heartbeat, but perhaps also with Earth's rotation, with the lunar orbit, with solar cycles that transcend conscious perception. The body knows things that the rational mind is unaware of, possesses wisdom embedded through millions of years of evolution under a cyclical sky, under the gravitational influence of the moon and sun, under circadian rhythms imposed by planetary rotation. You are a terrestrial creature, specifically adapted to the conditions of this world, to gravity of this magnitude, to atmosphere of this composition, to light of this specific star. And there is beauty in recognizing the particularity of this adaptation. You could not live comfortably on Mars, on Europa, on Titan, not with extensive technological support. But this is not a limitation. It is specificity. It is identity. It is belonging. You belong to Earth in the same way that a fish belongs to water, a bird belongs to air. It is not imprisonment. It is home. It is the place where every physical characteristic, every biological process functions in harmony with the environment. And there is profound satisfaction in this, a recognition of perfect fit between organism and habitat. The solar system has offered lessons of scale, of time, of diversity. It has shown that worlds can be radically different but equally valid, that there is no single way to be a planet, to have an atmosphere, to possess moons. It has taught that processes that seem violent, storms, eruptions, collisions, are natural parts of cosmic dynamics, neither good nor bad, just physical processes following natural laws. It has revealed that beauty exists on all scales, from dust particles reflecting sunlight to gas giants adorned with spectacular rings. And more importantly, it has demonstrated that everything is connected, not mystically, but physically, through gravity, through exchanges of material, through magnetic fields and radiations. The solar system is not a collection of isolated objects. It is a network of interactions. It is a system where each part influences others, where change in one place eventually reverberates throughout the whole. You are part of this network, connected through cosmic dust that falls constantly, through sunlight that warms skin, through lunar tides that move oceans whose saline aerosols you breathe. Now, as consciousness prepares to glide smoothly into sleep, you carry these images, these understandings, into the liminal region between wakefulness and rest. Not as facts to be memorized, not as information to be retained consciously, but as soft impressions, as sensations of serene vastness, as recognition of belonging to something greater. And these impressions will work silently during sleep, integrating into a deeper understanding of yourself and world, of cosmos, of your own place in the grand tapestry of existence. The solar system will continue to spin during your sleep. Jupiter will complete a small fraction of its 12-year orbit. Saturn will advance slightly on its 29-year path around the Sun. Uranus and Neptune, so distant, will move imperceptibly in orbits that last decades. And Earth, your home, will complete another rotation, bringing a new dawn, a new opportunity to observe, to learn, to simply be present under a sky that contains so many wonders. You feel heavy eyelids, completely relaxed muscles, a clear but quiet mind. There is no urgency, no pending task that cannot wait until morning. This moment is dedicated exclusively to rest, to allowing body and mind to recover, to renew, to prepare for a new day. And as you drift into sleep, the last consciousness is of gratitude. Gratitude for existing in this specific moment of cosmic history, on this specific planet in orbit around this specific star. Gratitude for the ability to contemplate the vastness and beauty of the solar system. Gratitude for the awareness that allows you not only to exist, but also to reflect on existence. The universe does not need your gratitude. does not need recognition or appreciation. It will continue independently of human thoughts or feelings. But gratitude is not for the benefit of the universe, it is for your own benefit. It is an emotion that enriches experience, that transforms abstract knowledge into lived connection, that adds an emotional dimension to intellectual understanding. And with that gratitude gently warming your heart, you finally allow sleep to come, for consciousness to dissolve into deep rest, for night to fulfill its role in the eternal cycle of light and darkness. Good night. Rest well under the invisible embrace of Earth's gravity, protected by the atmosphere that breathes along with you, illuminated by the reflected light of the moon that orbits faithfully. The solar system watches over your sleep, not consciously, not intentionally, but through billions of years of stability that allowed life to arise and flourish.
And tomorrow, when you wake up, the sun will be there, rising on the horizon, fulfilling the role it has fulfilled for 4.6 billion years, without fail, without hesitation, offering the light and heat that sustain everything you know and love. The planets will continue their silent orbits. The moons will continue their gravitational dances. Comets will trace paths through icy darkness. Asteroids will remain in the belts between Mars and Jupiter, patient witnesses to the formation of the solar system. And you, small but precious conscious being, will continue your own journey, orbiting the sun indirectly through Earth's orbit, traveling through the galaxy along with the entire solar system, participating in the great cosmic dance without the need for conscious choice, simply by existing, simply by being here, now in this singular moment that has never existed before and will never exist again exactly in this way. And this singularity does not bring pressure, it brings liberation. Each moment is unique, yes, but there are also infinite moments, an endless succession of presents that unfold continuously. You don't need to hold on to this moment tightly. You can let it flow. You can allow it to pass and trust that the next moment will come, bringing its own qualities, its own possibilities. Life is flow, not stasis, and resisting that flow causes suffering. But accepting, surrendering gently to the natural movement of time, that brings peace. The solar system has taught this lesson through its slow transformations, moons that spiral gradually, rings that dissipate over eras, orbits that change imperceptibly. Nothing remains exactly the same, but change happens at a pace that allows adaptation, that allows continuity within transformation. And you too can embrace this truth. You can allow yourself to change, grow, evolve, without fear of losing essence. Because identity is not static. It is a dynamic pattern. It is a continuous process. It is a river that keeps its name despite the water always flowing. Take one more deep breath, feeling the air going in and out, connecting you with the planetary atmosphere, with the carbon cycles that sustain life, with the oxygen produced by plants and phytoplankton during billions of years of photosynthesis. Each breath is participation in global systems, in networks of exchange that connect all living organisms. You are not isolated. You are not alone. You are not separate. You are deeply intertwined with the Earth's biosphere, with the planet's geology, with the global climate, with the orbit around the sun that determines seasons and cycles. And now, finally, allow the last conscious thought to dissolve. There is no need to hold on to the narrative, to review points, to analyze or categorize. Let everything simply be, simply exist as an experience that happened, as a journey that was completed, taken, as a gift that was offered and received. The solar system asks for nothing in return. It simply exists, offering itself for contemplation, for study, for wonder. And your attention was enough.
Your presence was adequate. Your consciousness was the universe's gift to itself. Matter organized in such a way as to be able to contemplate matter. Cosmos recognizing cosmos. Sleep well. The solar system guards your rest with loving indifference, with imperturbable continuity, with a presence that does not require recognition but offers profound comfort. You are a child of stars, an inhabitant of a blue planet, an observer of the cosmos. And these identities do not conflict. They complement each other, enrich each other mutually, create a totality greater than the sum of its parts. And with that totality gently embracing a consciousness that dissolves, you finally rest, complete, whole, in peace. If you enjoyed this journey through the most relaxing facts about the solar system, if you felt peace or fascination, or simply renewed curiosity about the cosmos you inhabit, consider leaving a like, sharing this space of calm and discovery with other people who might need a moment of serenity, or commenting your own reflections on the peaceful vastness that surrounds us. Each gesture helps to create a community of contemplators, of people who find comfort not in the denial of cosmic vastness, but in a curious embrace of it, who recognize that scientific knowledge does not diminish mystery, but deepens it, makes it richer, more textured, more worthy of continuous wonder. The universe waits, patient and eternal, for those who wish to look with gentle attention, with an open mind, with a receptive heart. And there is always more to discover, always new angles of understanding, always additional perspectives that transform the familiar into new again. But for now, for tonight, let it be enough. Let the journey end here, at this point of deserved rest, at this serene pause before deep sleep. The solar system will be there tomorrow, immutable in essence, but always offering new details for those who know how to look, new invitations for contemplation, new opportunities for connection between the human mind and cosmic reality. Good night, traveler. Rest in the depths of sleep, protected by billions of years of stellar stability, lulled by the gentle rotation of the planet you call home, illuminated by dreams that may carry echoes of distant stars, of alien planets, of the vastness that exists beyond the atmosphere, but also within every atom of your being. You are condensed cosmos, the universe looking at itself, and there is profound dignity in that identity. There is beauty that transcends words. There is peace that requires no justification. Simply rest and let everything be exactly as it is.